Hello, everyone. Hi, welcome to G2I's last event of the year, the new React Native architecture. I'm Thea, your community manager here at G2I, and today I am joined on stage by Andrei, who's also a member of the G2I Developer Collective. So Andrei is a senior developer who's specializing in React and React Native. He has been an early adopter of React Native and now has more than 5 years of experience with the framework. So today he's here with us because a lot of you have requested to hear more about the new React Native architecture, Fabric, including its pillars, JSI and Turbo Modules. So we're super happy to finally be bringing that to you. Before we get to the presentation proper, I'm just going to give you a bit of housekeeping. So um, during this session, you are very welcome to engage in the chat. It's a special opportunity to be hearing about the new React Native architecture with other people who are passionate about React Native. So feel free to interact with each other. You can also leave questions that you have for Andrei for after the session in the Q&A portion. So you can find that with the question mark icon on the right side of the screen. So Andrei's presentation is around 20 minutes, and after that, we're going to jump to Q&A until the half hour. But that's it for me. It was a short intro, just a bit of housekeeping, and now we're actually ready to bring him on stage and listen to what he's prepared for us.
All right, thank you, Thea. Let me start by sharing my screen here as well, so everybody can see my slides. There you go. All right, hello everyone. As you already know, my name is Andrei. I will present this talk about React Native's new architecture. This is an interesting experience actually because recently everyone doing online talks like this, we are recording them, but this time we're actually doing this talk live, and I'm finally feeling the anxiety related to doing a live talk like this, as it is when you're doing an in-person event. So it's cool because I actually enjoy this feeling. Beyond that, before I get into this talk, let me just clarify a few things, or at least point out that recently we had a few talks by React Native core maintainers, specifically Nicola and Lorenzo, and they've done an amazing job highlighting React Native's new architecture and specifically where we stand right now in the React Native community related to the new architecture. And in this talk, I don't want to repeat exactly what they said. What I'm going to try to do is explain a little bit of how I understand what the new architecture is and give you guys a perspective of someone who is not a React Native core maintainer and who's using React Native to build apps and have tried to update my app to the latest architecture. So the way I thought of approaching this is talking about the new architecture in a historical standpoint, and then later diving into the technical stuff. So historically, what is the new architecture, right? So far, we've been hearing these terms like Fabric, JSI, Coden, Turbo Modules, Spaghetti, or not really Spaghetti, but all of this actually started coming up, or it was all presented to us by Parashuram back in 2018 in the React Conf, and he came up in this talk telling us about how they are envisioning this new architecture for React Native. But many people might see this and start thinking, but why did he do that? Why are we having a new architecture? And Parashuram at the time pointed out like there were a couple of issues with React Native, specifically related to layout shifts, rendering blank areas, irresponsive gesture updates, right? When you're like swiping or dragging an item in the UI, you want the UI to update immediately. And that was an issue with the previous architecture, including, for example, you have some libraries in the open source community that try to solve this specific pain. For example, Reanimated, a React Native gesture handler. And beyond that, he also highlighted how we had some issues with slow app load times at the time. But how did Parashuram say that they were going to try to solve this. And he made a few points. The first one is that they were going to try to create this renderer that was going to allow for synchronous UI updates. And we're going to dive deeper into what that means later. And he also mentioned how lazy loading native modules was also going to improve app load times. And then lastly, he highlighted how some of these UI synchrony issue where the UI is out of sync with the user gestures was going to be solved by removing the bridge. But in hindsight now, as we are now in 2022, and we look back to 2018, we notice a few interesting things. For instance, back in 2018, Parashuram did not really mention anything about React concurrent mode. And he also left a feeling and implied an assumption that this was a performance improvement overhaul. Everybody in open source and everybody who was using React Native, when they heard this new architecture idea, presumed and assumed that that meant that there was a re-architecture because of performance. And that once we get this new architecture, we would see a completely different performing app. However, moving forward to 2022, as we are receiving more and more updates from the React Native core team, we notice that there are more and more highlighting how the reason for the architecture is React concurrent mode and how performance improvements are not really the focus. And evidence of this is from a recent thread where the React Native core team asked the community, hey, what do you want us to improve? And everybody talked about performance and talked about the new architecture and stuff. And a React Native core team member called Samuel Susla responded explaining that, I know that performance is an interesting point, but it's not our goal here. The goal of the new architecture was to fix some of these UI layout issues, plus enable the new React concurrent mode. And this was kind of a relief actually to me specifically, because we've been in the open source community, we've seen like people like Alexandri who has been conducting benchmarks and noticing like there are some things that React Native, the new architecture is better, but there are some things that's not actually better. It's like either equal or slightly slower. Given all the historical point that I just mentioned, just so you can understand where we are at now, let's dive into technically what is the new architecture and what is it made of. So the new architecture has a few pillars. The JSI, which it is the most important pillar of them all. I'm going to dive deep into trying to explain JSI in very layman's term next, but without JSI, nothing beyond here was going to be possible. Like everything that they did was they had to create JSI first for everything else to come afterwards. So after JSI, they were capable of doing this idea of turbo modules. And then we had Fabric, and then we had Coden. I'm going to talk about each one of these, and I'm just going to add a quick note. Well, not even going to add a quick note. Let's just keep going, and we'll talk about each one of them. So JSI, in probably an incorrect simplification of what it means, it's just a JavaScript interface that enables two-way communication between the native layer and the JavaScript layer, okay? I'm using layer instead of threads because they don't always have to be different threads. But I know everybody has heard about this JSI idea all over the place, and sometimes they probably might not really understand what it is. So why don't you explain it to me like I'm 5? And I'm going to try, but honestly, I'm probably going to fail because JSI is slightly not confusing, but there is some complexity to it. So for us to understand JSI, let's just quickly review like how did React Native app work without JSI, right? If you don't have a mental model of how React Native work, let's think of it this way. So React Native, when you run an React Native app on iOS, let's just think about iOS for now. When you run an iOS app, the iOS operating system reads that app's Objective-C code, right? The Objective-C code determines what is displayed and what logic to run. So technically, a React Native iOS app is just a native app, literally running on the platform. Within the Objective-C code, React Native instantiates a JavaScript runtime that is a JavaScript engine. And typically, just a special note here, JavaScript engines are typically written in a low-level language like C or C++. And the JS engines like JSC is written in C++. And you can actually call that engine and embed that engine directly in Objective-C because Objective-C allows for interrupt, for native interrupt without any problems. They use something called C headers, in case you're interested. So this allows the Objective-C app to literally just run JS, and it'll take your parsed, so hold on. So Objective-C runs your JS engine, and it takes your JavaScript, your bundled JavaScript, stringified bundled JavaScript, and passes to that engine to let it run and give the results. In order to communicate with the JS engine, it extends the JS engine by having this bridge function. And all this bridge function does, it's just a simple event emitter function that takes a command as a first argument and a stringified data as a second argument. This bridge function will dispatch an event that the native layer is listening, and it can do that in the other way around as well. If you think about this historically, like if you start to think about it, if you were to implement a similar idea to React Native, this is the easiest way to go, to have just this one function that can take a command ID and a stringified params as a second argument, as a way to communicate between both layers. Because if you don't do this, you would have to write C headers for every method you want to communicate between these two layers, right? So that gets a bit complicated. Like a good way to think about this of why we do this is because the JS engine is a private class, right? It's a private manager. You don't have access to the internal stuff inside of the JS engine, and vice versa. So imagine a class with like multiple private methods. You don't have access to it. So you could so instead of implementing access to every method, you just implement a dispatching method that takes a method name plus its arguments to the internal method of each class. And that is currently how we had this React Native bridge that everybody has heard of, and why they say, oh, all of your params are serialized when you're passing it through the bridge. It's not because they are in different threads, but because React Native was initially very lazy to implement this. They just wanted the easiest way to do it, and this was the easiest, most scalable way to do it. So they just built around this idea. However, with JSI, they start extending the idea of the shared memory interface here. And they replace this single bridge function that we have to dispatch commands both ways for actual in-memory interfaces. But remember that I said that if you were to do this yourself initially, how the bridge function would be the easiest way, because another way would be implementing C header interfaces to communicate between both layers for every method you needed. So they created an abstraction, and that will do that for you in a very easy way. So you can register any method from each side of the layers to say, hey, this is a callable method, or this is a readable variable from the other side. And that's what JSI is. It gives you that ability to interrupt between these two layers without being difficult. And all of this is true for Android as well, with the exception that on the Android layer, either using Java or Kotlin, that you don't have native interrupt. You need to extend your Java code to use something called JNI, which is a package that allows for that native interrupt. So with JSI now, you have this idea of host objects, which are exactly what I just told you, is that you're defining these methods or these objects that are accessible in both layers. And that gives you in-memory reference. So you got type support you can define primitives for almost everything, like string, function, big int, symbol, number, and more. There's a source code for this where you can look at all the accepts the stuff. And this is like the foundation to everything else. So once you understand, like, this is extending how both layers can communicate, but not both layers, specifically how the JavaScript engine can communicate back with the owner that's running it, right? Which in this case in iOS, it would be like the Objective-C code that's managing it, that's running the JS engine. So once they did this, and I was actually following the development of this during my React Native Weekly that I was doing last year, and I saw this happening as they were implementing it. So this has been done for like 2-3 years now, and there has been implementations of it. But everything that came after the JSI was implemented is what took a little bit longer. Next, we have the Turbo modules. So again, built on top of JSI, and it will allow you to also implement this lazy loaded modules idea that Parashuran mentioned all the way back in 2018. This is still a work in process. This is it's said to be targeted to be delivered next year, so we'll see. But what Turbo module is just removing the bridge from the native modules. Instead of having the bridge, you have a native module that uses JSI directly. So you're defining these JSI methods, like I said, like the host objects to communicate. And while Turbo modules is continually like presented separately, or so, it technically builds on top of CodeGen as well. It's tightly correlated to one another, and I like to explain that. And one thing that I noticed, like in my perspective, this is not React Native core team's perspective, but my perspective from watching this from the side is like CodeGen is part of the new architecture because it is like a tooling that comes along with it, but it's not exactly the re-architecture, right? It's just a tool that was created to help with the re-architecture, specifically for generating modules, native modules. So what CodeGen does is it's a code generator. So it lets you specify this configuration file that is just a type definition file that it says, hey, I have a native module and it takes this prop and please generate this module for me. And what it does, it doesn't exactly generate the module for you, but it generates header files in Java, in Kotlin, in Objective-C. Now, why is that interesting? So header files dictate implementation files, and that makes that enforces type definitions. That makes it strict and type safe. So that is the whole goal with CodeGen, is to make sure that when I have a module here, a native module, it's type safe in all platforms. So I can expect the same implementation in all platforms. So that's an interesting thing. And it also, of course, removes verbosity. What you're seeing here is an example of a spec file for an actual native view module, right? So this person here implemented a native props for a view that extends view props. It's a native view module that has a special prop called image. In this other place, this is an example for just a normal native module that you can call its method and have listeners, etc. I will later share my slides, and all of this are actually links, so you can go and dive deeper into these things. And then finally, we arrive at Fabric. Fabric is literally code name for concurrent mode in React Native, right? In React, it's called Fiber, so that's why, I don't know if you guys heard of that, but React is called Fiber, so it's just one fiber, and the Fabric is a mix of fibers or a set of fibers. So the idea of enabling concurrent mode in React Native required JSI because it required a synchronous UI manager, all right? So before JSI, before the new architecture, the UI manager that is responsible, so this is a native class in React Native that is responsible for like telling the platform to render X item. Previously, it was asynchronous, and it couldn't be asynchronous and be concurrent at the same time because it didn't know how to handle scheduling priorities. That's a very important point. So what this new Fabric built on top of JSI enables is for the Fabric UI manager, it now extends it to support like concurrent scheduling. which is something that the React 18 is required to support with its features. So when you hear the idea, and this is interesting because it's like driving the point on how, hey, the new architecture is exactly about this. It's about enabling concurrent mode. Nicola, in one of his talk recently, also highlighted how React 18 is going to impact React Native and which versions are allowed. So if you enable React, if you're on the latest version of React Native now and you enable the new architecture, you would have React with concurrent mode. You would have React 18 with concurrent mode. But if you don't enable the new architecture, you're going to be on React 18, but it's a React 18 without concurrent mode. And he drives his point here to say also that React Native is shipping with a React renderer within its code. So even if you go to package.json and you change the React version that you have, it's not going to reflect in your app because React Native is not using that React renderer. It ships its own React renderer that you can find in the repository here. So with Fabric, you have access to React 18's new concurrent features. And if you've been following along, you heard about start transition, use deferred value, full suspense support. And to this point, and right here, I like to highlight React, in my perspective, again, because I need to make sure people don't think that I'm speaking for the React Native core team, is while the new architecture will not directly mean better performance, the React 18's concurrent mode does mean a better user experience and does allow you to have better, more responsiveness in your app than you had before, which could result in a increased, what's the right word? In an increased perceived performance. That's the right word. So with these features, it will allow you to implement apps that have higher perceived performance than they had before, even though in the core metal, it's not more performant. And if you haven't heard, if you've been, I don't know, in a cave somewhere and you haven't heard of concurrent features in React, you can watch Dan's Iceland talk back in 2018 as well, where he introduces the idea. It's all about scheduling priorities, right? You want to respond to user inputs immediately and not let any ongoing rendering work block that. So that's what React Concurrent is all about. And that's why it helps React Native in a sense, because think of a list or think of a gesture handler where you're dragging stuff around. You want that event to be prioritized over everything else because that's the most important thing. And you can do that with React Concurrent mode. So I'm going to kind of summarize all of the current takeaways of where React Native architecture is at, and so that you can start thinking about how this impacts you in your work. So these are things to know in Q4 2022, and I'm highlighting Q4 2022 because you will see that things are changing at a very rapid pace. For instance, if you don't know, there is a working group discussion here that has all of where people are coming back with feedback. Third-party libraries migration status can also be found here. There's a bunch of libraries that have not yet been migrated. For example, bottom sheet has been migrated, so this is not updated. But you should probably list out all of your native modules and keep track of when they have been migrated or not. All of the native modules supported by software mentioned has been migrated. So for me, like in my app, that's a big blocker because I use React Native screens, I use Reanimated, I use React Native gesture handler. They are all Fabric ready. Oops, let's go back. Expo 47 started rolling out support for the new architecture. It's experimental support, but this is about like a month old now. Probably you're going to see Expo fully supporting Fabric very soon, but it has a much bigger ecosystem behind it, and it has to implement support for everything. So watch for that. I think Expo might be the turning point. Like once Expo is ready, I think everybody's going to be ready. Very interesting highlight that I want to make is Expo modules support Fabric. If you haven't heard of Expo modules, but it is a tool to help you create native modules. It gives you default support for Swift and Kotlin in your native modules. It already gives default support for Fabric. If you're building a native module right now, you should use Expo module as a tooling for that because it's going to make your life so much easier. Very React Native apps can easily leverage Expo's ecosystem as well. I've been here long enough to know like there were a lot of prejudice against Expo because that Expo was also you could get like vendor locked in with Expo and then you had to eject from an Expo app. All of that has completely changed. Expo is very easily consumable in a React Native Bear app. All you have to do is install the Expo modules. It's like a 1 kilobyte thing. It's very small, and you can use all of the Expo ecosystem once you do that. So you should probably look into it if you haven't. An easier interop layer might come. So React Native core team has heard the feedback from the community. Everybody complained how enabling the new architecture was difficult. It's very verbose, especially adding backwards support for the old architecture. It requires you to duplicate a bit of code natively, and it's a lot of C++ code. They've heard of it, and they are trying to work on extending an interop layer to allow the old architecture to function with the new architecture at the same time, giving more time for everyone to migrate. So again, this is changing at a very rapid pace. Things to look out for example, there are some sample repos that was created by React Native core team. This one is for how to migrate to the new architecture in your apps. This is very helpful. Like this has made my life so much easier. They have like commits explaining exactly what you got to do to change. The React Native architecture has a simple repo for libraries as well. Let's say you're implementing a specific kind of module. They are summarizing what has to change by commits. Has been so helpful. So if you haven't heard of this, you should look into it. And also, this is a good source to understand what needs to change and understand like what's different now. Conclusion. Finally, just to finalize, you need to think if you're an engineer and you support a React Native app, you need to start thinking like, when should I start migrating? When should I start enabling the new architecture? I'm gonna give you my perspective of, depending on your size, if you're part of a big corporation, you should get involved immediately. You should have been involved since Q3. We need big corps with money that can invest to be involved in the open source effort of the new architecture. And you should be already trying because this is something that's interesting for everyone. If you're a small team and you don't have the capacity to invest in this, perhaps you should wait. But in my opinion, the best alternative is to get behind the Expo train. Expo is doing lots of lift in the developer experience layer. It's implementing support for Fabric for many modules as well, alongside software mentioned. So if you don't want to do too much heavy lifting, you can just get behind Expo using Expo modules and all of that, and it's just going to be a lot easier for you. In my experience, in particularly, Q3 2022 was a bit too early for us. Of course, but I'm part of a big corporation, big company. We had it was part of our budget to make investments in this area. So we tried to enable the new architecture in Q3. It did not work out as planned, but we did move the needle. We were able to help migrate a couple of native module migrates in the open source. We also found some interesting strategies, like for example, we don't exactly need all these native modules. Sometimes you can evaluate that. For instance, React Native linear gradients. We found that we don't need React Native linear gradient if we have React Native SVG. This React Native SVG has linear gradient support. Also, in some cases, we looked into JavaScript only alternatives like the React Native tab view. It leveraged a native tab view, and we found that we could have a similar behavior using just a JavaScript only tab view. So all of this needs to be taken into account. In our case, our code base is now new architecture ready because we removed set native props. We removed find node handle and all the measure callbacks that are no longer allowed. Of course, that if React Native core team improved the interrupt layer, maybe some of these changes weren't going to be required, but they have warned everyone that these UIs or these APIs have been deprecated. So it's interesting for you to remove them from your code base. The last thing from my experience that we found interesting is, like, for instance, I don't know if you've heard of set native props. It's just a way to set props on a native view by skipping the render, by not having to go through the UI re-render or the React re-render. And we found that we could replace that with reanimated by using shared values. So that's an interesting thing as well. Then finally, Q1 2023 is very promising. I really loved how the React Native core team asked the community about how do they feel, the things that needs to be changed. And I saw a lot of positive feedback, or a lot of good feedback about developer experience and how debugging experience could be a lot better. And they have given us a clear sign that they're going to work on these things. And lastly, the new architecture is exciting, especially if you make use of React concurrent mode and suspense a lot in your app. It should make the user experience a lot better. I will share these slides in the chat so everybody can look into these links. We're also going to be posting a blog post about this entire presentation. Like, everything I just said is written somewhere. So I'm going to post that as a blog post in the G2I blog as well, so everybody can reread anything that I said over there. I hope you enjoyed. That's it. Thank you.
Perfect. Thank you so much, Andrei. I'm just gonna remove the slides. Perfect. So we are already at the half hour, actually, but before we end, I'm going to ask one question that one of our developers has asked me to ask you. So just to give him that favor before we say goodbye, I have a question here from Juan for you, Andrei. So to confirm, in order to opt in for the new architecture, do all the libraries and packages of the app need to support it? If one of the libraries doesn't support it, will the app not work? So that's the question.
That's correct. It does need to support it, especially the native view modules. They need to support it. That's where they're trying to extend the interrupt layer. So like some native modules might work, but it's not very clear which ones do and which ones don't. So the default answer to that question is you need everything to be migrated.
Perfect. Amazing. So actually, that was one question that we had from the crowd. We're actually going to wrap it up here because we're at the half hour. But what we're going to do is, we can carry this conversation over on Slack. As I mentioned, Andrei is a member of the G2I collective, so he'll be online. He's somebody that you can reach out to if you would like to discuss further, learn something from him, collaborate, stuff like that. But anyway, Andrei, thank you so much for being with us. I'm sure that a lot of people enjoyed. We have a lot of people who stayed from beginning until the end. I'm really happy to close the year, finally being able to, present this topic to our group of developers. Thank you for your time, Andrei. Thanks for the presentation. And thanks to everyone who have been here with us today to support us for our last event of the year and to just continuously support the G2I community.